You're floating in darkness so complete that up and down lose all meaning. The pressure around you is crushing, literally tons of water pressing in from every direction. Yet somehow, impossibly, you're safe in this tiny bubble of light and warmth, descending deeper and deeper into an alien world that covers most of our planet, but remains more mysterious than the surface of Mars. Strange shapes drift past your window, creatures that look like they were designed by a fever dream, pulsing with their own cold light. And then, in the distance, you see something move, something big, something that shouldn't exist. Welcome back to Midnight Deep Dive. Or if you're new here, welcome to our cozy corner of the internet, where we explore the fascinating mysteries that have captivated human imagination throughout history. Tonight, we're descending into the depths to explore 10 of the ocean's most enduring mysteries. The ocean covers 71% of Earth's surface, yet we've explored less than 5% of it. In those dark, crushing depths, creatures exist that seem to violate everything we think we know about biology. Sounds emerge that we cannot explain. Shapes appear on sonar that match no known animal. So settle into your most comfortable position and join me as we explore 10 of the deep sea's most captivating mysteries. In the summer of 1997, an array of underwater microphones positioned throughout the Pacific Ocean detected something extraordinary. The sound was picked up by sensors more than 3,000 miles apart, suggesting a source of almost unimaginable power. It was ultra-low frequency, rapidly rising in pitch over about 1 minute, and unlike anything in the database of known ocean sounds. Scientists at the National Oceanic and Atmospheric Administration, NOAA, gave it a simple, almost comical name that belied its mysterious nature: the bloop. The bloop was loud, exceptionally loud. To put this in perspective, the loudest animal on Earth is the blue whale, whose calls can reach 188 decibels and travel hundreds of miles underwater. The bloop was detected across thousands of miles, suggesting a source far more powerful than any whale. When you listen to the bloop, and you can, it's been released publicly, it sounds organic. It has a quality that resembles animal vocalizations, particularly when it's sped up to a frequency our ears can better process. It sounds, for lack of a better description, alive. This organic quality immediately sparked speculation about what could have produced such a sound. The most exciting possibility, the one that captured public imagination and refuses to entirely let go, was that something enormous and unknown lurked in the ocean depths. Something big enough to produce a call that could be heard across an ocean basin. Something that had somehow evaded human detection for all of recorded history. The timing of the bloop's discovery coincided with renewed interest in giant squid and the first live footage of these creatures in their natural habitat. For centuries, giant squid existed in a strange space between myth and reality. Sailors told stories of enormous tentacled beasts that could pull ships beneath the waves. Marine biologists found beaks from giant squid in the stomachs of sperm whales and occasionally encountered dead specimens washed ashore. But no living giant squid had been photographed or filmed in the deep ocean. When Japanese researchers finally captured footage of a live giant squid in 2004, it confirmed that the ocean still held large animals we'd barely glimpsed. If giant squid could remain mostly hidden until the 21st century, what else might be down there? The bloop seemed to suggest that the answer might be something even larger, even stranger. Cryptozoology enthusiasts proposed everything from unknown whale species to surviving populations of prehistoric marine reptiles. The most popular theory involved some kind of gigantic cephalopod, a squid or octopus of truly enormous proportions that lived at depths humans rarely explored. Marine biologists cautioned against jumping to fantastical conclusions, but they also couldn't immediately explain the sound. The ocean is full of sounds we don't fully understand. Whales, dolphins, fish, shrimp, and countless other organisms create an underwater symphony that that varies by location and season. But the bloop didn't match any known biological source. Its pattern and frequency were unique, and its volume was unprecedented. The mystery deepened when researchers realized that the bloop wasn't alone. The underwater listening arrays, originally installed during the Cold War to track Soviet submarines, had detected numerous other unexplained sounds over the years. These sounds were given whimsical names by the scientists who studied them: upsweep, whistle, Julia, slow down, train. Each represented an acoustic anomaly that didn't match known sources, creating a catalog of ocean mysteries. For years, the bloop remained unexplained, fueling speculation and imagination. It appeared in documentaries about ocean mysteries, featured in discussions about undiscovered species, and became a touchstone for those who believed the ocean still held secrets that science hadn't uncovered. The sound became almost mythical itself, a modern mystery that seemed to suggest the ocean could still surprise us in fundamental ways. Then in 2005, NOAA scientists announced they'd solved the mystery. The bloop, they determined, wasn't biological at all. It was cryogenic, the sound of ice. Specifically, it was the sound produced by massive icebergs cracking and breaking apart, a phenomenon called icequake. The sound occurred in the vicinity of the Bransfield Strait, near Antarctica, a region where large icebergs regularly calve from ice shelves and fracture. The explanation made scientific sense. Ice cracking under tremendous pressure and tension can produce incredibly loud sounds that travel vast distances through water. The frequency pattern of the bloop matched what you'd expect from ice fracturing events. The timing coincided with the Antarctic summer, when iceberg calving is most common. Multiple icebergs breaking up could produce the varied acoustic signatures that had been detected. For many, this explanation was disappointing. The bloop transformed from potential evidence of unknown ocean giants to simply a particularly dramatic instance of ice doing what ice does. The mystery dissolved like ice melting in warming seas. The romantic notion of undiscovered monsters lurking in the abyss gave way to the more prosaic reality of geological and cryogenic processes. But the scientific explanation, while less thrilling than giant sea creatures, reveals something perhaps equally fascinating about our planet and our perception of it. The ocean is so vast, so deep, and so full of complex physical processes that even sounds produced by ice can seem otherworldly and inexplicable when we first encounter them. The fact that we're still discovering and cataloging the ocean's acoustic environment in the 21st century demonstrates how much we don't know about this world we inhabit. The bloop also highlights an interesting aspect of human psychology. We want there to be monsters. We want the ocean to hold secrets and surprises. The idea that vast portions of our planet remain unexplored, that unknown creatures might swim in depths we've never reached, appeals to something fundamental in human imagination. We're pattern-seeking creatures who evolved to find agency and intention in the world around us. When we hear a sound that seems organic, seems purposeful, seems alive, we naturally imagine some living source. This tendency isn't foolish or ignorant. It's part of what drove human exploration and scientific discovery. Our ancestors who imagined threats in ambiguous sounds were more likely to survive than those who dismissed every unknown as harmless. The same cognitive bias that makes us hear the bloop and think giant creature also helps us notice genuine patterns and make connections that lead to real discoveries. Moreover, the disappointment some felt at the bloop's explanation suggests something beautiful about human nature. Our capacity for wonder, our hope that the world still holds mysteries. In an age where satellites photograph every square meter of land surface, where we carry devices that can access almost any information instantly, where so much seems known and cataloged, the ocean represents one of the last truly unexplored frontiers on Earth. We want it to surprise us. We need it to remain mysterious. And here's the thing, it does. While the bloop itself wasn't evidence of unknown creatures, the ocean absolutely contains species we haven't discovered yet. Marine biologists estimate that we've identified perhaps only 10% of ocean species, with the vast majority of undiscovered organisms being small invertebrates, microorganisms, and fish, rather than enormous cephalopods. But large unknown species are discovered periodically. New whale species have been identified in recent decades. The megamouth shark, growing up to 18 feet long, wasn't discovered until 1976. The ocean keeps its secrets well. The story of the bloop reminds us that mystery and science aren't opposites. Scientific investigation of mysteries doesn't destroy wonder. It reveals different kinds of wonder. Ice sheets the size of small countries breaking apart in Antarctic waters, producing sounds that travel across ocean basins, represents a reality no less remarkable than any fictional sea monster. The processes that shape our planet, the forces that move continents and grind glaciers, create phenomena that challenge human comprehension. So while the bloop wasn't the call of some unknown leviathan, it was the voice of Earth itself. Ice that had been frozen for thousands of years fracturing as climate patterns shifted, breaking free and drifting into warmer waters. In its way, that's just as profound as any creature could be. The bloop reminds us that the ocean is active, dynamic, and full of processes we're still learning to understand. For thousands of years, sailors returned from voyages with tales of enormous tentacled beasts that rose from the depths to pull entire ships beneath the waves. They described creatures the size of islands, with arms like ships' masts and eyes like dinner plates. These weren't isolated accounts from a single culture. Stories of massive cephalopods appeared in Norse sagas, Mediterranean folklore, Caribbean pirate legends, and Japanese mythology. The creature had many names, but it's best known by its Norse designation, the Kraken. The earliest written accounts of the Kraken come from Scandinavian sources, where it was described as a creature so large that sailors sometimes mistook its back for an island. According to these tales, the Kraken would float motionless on the surface, barnacles and seaweed growing on its body, creating the appearance of solid ground. Ships might even anchor nearby, and sailors might row to this island to gather fresh water or explore. Then suddenly, the Kraken would submerge, creating massive whirlpools that dragged ships and men down to their deaths. Erik Pontoppidan, a Norwegian bishop who wrote a natural history of Norway in 1752, provided detailed descriptions of the Kraken that influenced European understanding for generations. Pontoppidan described a creature so enormous that its body measured 1.5 miles in circumference. He claimed that when the Kraken surfaced, its back rose above the waves like a series of small islands. The real danger, according to Pontoppidan, wasn't the creature's aggression but its size. When it descended back into the depths, the displacement of water created currents and whirlpools powerful enough to sink ships. Pontoppidan also noted that areas where the Kraken was known to surface tended to have unusually good fishing. His explanation was that the Kraken's excrement provided nutrients that attracted fish, making these dangerous waters paradoxically profitable for brave fishermen willing to risk encounters with the beast. This detail adds a curious verisimilitude to the account. It's the kind of practical observation that suggests first-hand experience rather than pure fantasy. These accounts weren't dismissed as mere superstition by educated Europeans. Natural philosophers and early scientists debated whether the Kraken existed, with some arguing that the consistency of reports across cultures and centuries suggested some real animal basis for the legends. The scientific revolution was underway, and the natural world was revealing itself to be far stranger and more diverse than previously imagined. Who could say definitively that enormous cephalopods didn't lurk in unexplored ocean depths? The challenge was that no physical evidence existed. No Kraken corpses washed ashore. No preserved specimens appeared in collectors' cabinets of curiosities. The creature existed entirely in testimony and folklore, which made it scientifically problematic. How could naturalists classify and study an animal that left no tangible trace? Then, gradually, evidence began to accumulate. Whalers hunting sperm whales in the 18th and 19th centuries found massive squid beaks in the stomachs of their catches. These beaks were far larger than anything that could come from known squid species. Something big enough to be prey for sperm whales, themselves enormous animals, was living in the ocean depths. Occasionally, dead squid of unusual size would wash up on beaches, their bodies damaged by wave action and decomposition, but clearly representing creatures far larger than common squid. The first scientifically documented encounter with what we now call the giant squid occurred in 1853, when a Danish naturalist named Japet Steenstrup examined a massive beak that had washed ashore. He recognized it as belonging to a huge cephalopod and gave it a scientific name, Architeuthis dux. This wasn't just folklore anymore. It was a legitimate biological species, even if scientists had never seen a living specimen. More evidence followed. In 1861, the French warship Electon encountered a giant squid near the Canary Islands. The crew attempted to capture it, managing to loop a rope around it, but the animal's body was too soft and heavy. It broke apart as they tried to haul it aboard, and most of it sank back into the ocean. They managed to retrieve only the tail end, but it was enough to prove that these creatures existed and could be enormous. The real wave of giant squid discoveries came in the 1870s in Newfoundland, where an unusual number of giant squid washed ashore or were found floating dead in bays. Local fishermen, initially terrified, eventually began collecting specimens for naturalists. These Newfoundland specimens allowed scientists to finally study giant squid anatomy in detail. They confirmed that these creatures could have bodies up to 13 feet long, with tentacles extending the total length to over 40 feet. Their eyes were indeed enormous, the largest in the animal kingdom, approaching the size of dinner plates. As scientific understanding of giant squid grew, the relationship between fact and folklore became clear. Yes, enormous squid existed. Yes, they had tentacles and huge eyes, matching sailors' descriptions. But the exaggerations were significant. Giant squid weren't large enough to pull ships under or be mistaken for islands. They were deep-sea creatures that rarely approached the surface, and when they did, it was usually because they were sick or dying. The healthy, active predators that sperm whales hunted in the deep abyss were never encountered by surface ships. The actual behavior and ecology of giant squid remained mysterious well into the modern era. All the specimens studied were dead, often in poor condition. How did these creatures live? How did they hunt? How did they interact with sperm whales, their primary predator? For over a century after being scientifically documented, the giant squid's life remained almost entirely unknown. The breakthrough came in 2004, when Japanese researchers Tsunemi Kubodra and Kyoichi Mori photographed a live giant squid in its natural habitat for the first time. They accomplished this by attaching a camera and bait to a long line deployed at depths where sperm whales were known to hunt. The photographs showed a giant squid attacking the bait, revealing its hunting behavior and demonstrating the creature's strength and aggression. The squid became entangled in the line and eventually broke free, leaving behind an 18-foot tentacle section that the researchers recovered. 3 years later, in 2007, the same research team successfully captured live video footage of a giant squid, showing the creature swimming and hunting in its natural deep-sea environment. This footage finally brought the giant squid out of mythology and into vivid reality. The creature was beautiful in an alien way, silvery and streamlined, moving with purpose through the black depths, its huge eyes reflecting the camera's lights. But the giant squid story has another chapter. In 2007, New Zealand fishermen caught an even larger squid species in Antarctic waters. The colossal squid, Messinichotuthis hamiltoni. While giant squid are longer, colossal squid are much heavier and more massive, with a more robust body, larger fins, and tentacles armed with rotating hooks in addition to suckers. The specimen caught in 2007 weighed approximately 1,090 pounds and measured about 33 feet long, but based on beak sizes found in sperm whale stomachs, scientists believe colossal squid can grow much larger, potentially exceeding 46 feet in length and weighing up to 1,650 pounds. The colossal squid remains even more mysterious than its giant cousin. Only a handful of specimens have been examined, all dead or dying when found. No one has photographed a live colossal squid in its natural habitat. These creatures live at extreme depths in Antarctic waters, making them extraordinarily difficult to study. They represent an apex predator in one of Earth's least accessible environments, the frigid, dark waters near the Antarctic continent. The transformation of the Kraken from legend to science reveals something profound about how human knowledge evolves. The sailors who reported enormous tentacled creatures weren't hallucinating or lying. They were observing real animals and interpreting those observations through the frameworks available to them. Their descriptions were exaggerated, certainly. Fish stories tend to grow with retelling, but they contained kernels of truth. When beaks and tentacles appeared in the gut contents of whales, when occasionally a giant squid surfaced and terrified fishermen, when bodies washed ashore showing anatomy unlike any familiar creature, people told the stories they could tell, using the language and concepts they had. Science didn't disprove the Kraken. It refined it, measured it, classified it, and eventually photographed it. The giant squid and colossal squid are no less remarkable for being real rather than mythical. A creature with eyes the size of basketballs, living a mile or more below the surface, hunting in absolute darkness using bioluminescence and sensitivity to tiny water movements. That creature is as strange as any monster imagined in ancient tales. Imagine a place on Earth where the pressure is so intense that it would instantly crush almost anything not specifically adapted to survive there. A place where the weight of the ocean above presses down with more than 8 tons of force on every square inch, where no sunlight has penetrated for millions of years, where temperatures hover just above freezing, where the entire ocean's weight creates an environment more hostile than the surface of most planets in our solar system. This place exists at the bottom of the Mariana Trench, in a region called the Challenger Deep, where the ocean floor lies nearly 7 miles below the surface. The Mariana Trench is a crescent-shaped scar in the Pacific Ocean floor, stretching for over 1,500 miles near the Mariana Islands. It formed where the Pacific tectonic plate slides beneath the Philippine plate in a process called subduction, creating a canyon in the ocean floor deeper than Mount Everest is tall. If you placed Everest at the bottom of the Challenger Deep, its peak would still be over a mile underwater. The scale is almost incomprehensible to human perception. For decades after its discovery in 1875 by the British ship HMS Challenger, the Mariana Trench remained beyond human reach. We could measure its depth using sonar, we could map its contours, but we couldn't visit it. The pressure at those depths made descent impossible with existing technology. It wasn't until 1960 that humans finally reached the bottom, when Swiss engineer Jacques Piccard and U.S. Navy Lieutenant Don Walsh piloted the bathyscaphe Trieste to the deepest point on Earth. Piccard and Walsh's descent took nearly 5 hours, slowly sinking through darkness that grew absolute after the first 1,000 feet. Their vessel, the Trieste, was essentially a large metal sphere capable of withstanding the enormous pressure attached to tanks of gasoline, which is less dense than water and provided buoyancy. As they descended, the sphere's metal walls groaned and creaked with the increasing pressure. They sat in near-total darkness, watching pressure gauges climb to levels no human had ever experienced, knowing that any structural failure would mean instant death. When they finally reached the bottom at 35,814 feet, they spent only 20 minutes there before beginning their ascent. But in those 20 minutes, they made an observation that changed our understanding of life on Earth. Through the viewport of the Trieste, in the beam of their searchlight, they saw a flatfish. A creature adapted to life at the absolute limit of ocean depth, where we'd assumed complex life couldn't exist. Life had found a way to colonize even this most extreme environment. It would be over 50 years before another human returned to the Challenger Deep. In 2012, filmmaker James Cameron made a solo descent in the specially designed submersible deep-sea Challenger, spending several hours on the bottom, filming, collecting samples, and observing this alien landscape. Cameron described the bottom as a lunar landscape of pale, fine sediment, largely featureless, a desert of mud under crushing pressure and absolute darkness. But between those two human visits, and in the years since Cameron's descent, we've learned that the deep trenches, far from being barren, host unique ecosystems with creatures found nowhere else on Earth. Remotely operated vehicles and sophisticated cameras have revealed a world that seems to violate our understanding of where life can exist and what forms it can take. The creatures of the Hadal Zone, the deepest ocean regions below 20,000 feet, display remarkable adaptations. Many are amphipods, shrimp-like crustaceans that in shallow water rarely exceed an inch or two in length. But in the trenches, some species grow to over a foot long, displaying the phenomenon of deep-sea gigantism we'll explore later. These superamphipods are voracious scavengers, able to strip a fish carcass to bones in hours, their metabolism adapted to the extreme pressure and cold. The trench also hosts sea cucumbers, translucent and ghostly, crawling across the bottom sediment filtering nutrients. Single-celled organisms called xenophyophores can grow to 4 inches across, enormous for a single cell. Strange jellyfish pulse through the darkness. Fish with translucent skulls and upward-pointing tubular eyes drift in the water column. It's an ecosystem based not on photosynthesis, which requires sunlight, but on chemosynthesis and the slow rain of organic material from above. A constant shower of dead organisms, feces, and organic debris that settles from the more productive surface waters. This marine snow, as oceanographers call it, provides the energy foundation for life in the deep ocean. In the trenches, this material accumulates in the sediment, creating an organic-rich environment that supports remarkable biological density. Studies have found that trench ecosystems can support biomass levels comparable to much shallower waters, despite receiving only a tiny fraction of the energy available to surface ecosystems. But the Mariana Trench holds mysteries beyond its strange inhabitants. Scientists have detected unexplained sounds originating from the trench depths, low-frequency noises that don't match known geological or biological sources. Some of these sounds might be related to volcanic activity or tectonic movements in the subduction zone. Others remain puzzling, adding to the trench's mysterious atmosphere. There are also structural mysteries. Parts of the trench system include deep pools and basins that are even deeper than the main trench floor, creating isolated pockets where water circulation is limited and conditions are especially extreme. What lives in these ultra-deep spots remains largely unknown. The difficulty of accessing them means they've been visited only a handful of times, if at all. Recent explorations have revealed something troubling about even our deepest oceans. When Cameron reached the bottom in 2012, among the strange creatures and fine sediment, he found plastic bags and other human debris. Subsequent expeditions have found microplastic particles in the sediment and in the bodies of deep trench organisms. Pollutants that we assume would stay near the surface are making their way to the deepest parts of the ocean, contaminating even these remote environments. The chemistry of the trench environment is also extreme in ways that make survival seem impossible. The high pressure affects how molecules interact, changing the properties of water itself. Proteins that would denature under such conditions have evolved special structures. Cell membranes require unique lipid compositions to remain flexible. Every aspect of biochemistry must be adapted to function under 8 tons per square inch. Some of the most intriguing mysteries of the Mariana Trench involve what we haven't found. Given the diversity of life we've discovered in other extreme environments, it seems likely that the trenches host species we haven't yet encountered. The vast majority of the trench has never been visited or photographed. The few expeditions that have descended there have covered areas equivalent to exploring a few parking lots in an entire continent. What lives in the unexplored miles of trench floor? Moreover, the Mariana Trench is just the deepest of many ocean trenches. The Tonga Trench, the Philippine Trench, the Kermadec Trench. Each has its own hadal ecosystem, and evidence suggests that these trenches might host endemic species found nowhere else. The trenches are effectively isolated ecosystems, separated by miles of shallower, deep ocean that serves as a barrier to migration. Life in each trench may have evolved independently, creating unique assemblages of species that we've barely begun to document. The trench also raises questions about the limits of life on Earth and potentially on other worlds. If life can thrive at the bottom of the Mariana Trench under such extreme pressure and in complete darkness, what does that tell us about where else life might exist? Jupiter's moon Europa has a subsurface ocean covered by miles of ice. Saturn's moon Enceladus has similar features. If life can adapt to the Mariana Trench, perhaps it could adapt to these alien oceans as well. As we develop technology to explore the deep ocean more thoroughly, the Mariana Trench reminds us that Earth still holds frontiers. It reminds us that we live on a planet we don't fully understand, where vast regions remain as alien and unexplored as any world orbiting a distant star. The deepest parts of our ocean are, in many ways, more remote and less accessible than Mars. We have rovers on Mars, satellites photographing its every square meter. But the bottom of the Mariana Trench, we've been there fewer times than we've been to the moon. This should be humbling and exciting in equal measure. Our planet isn't fully known. Its deepest places harbor mysteries, strange creatures, and phenomena we're only beginning to understand. The Mariana Trench is a reminder that wonder doesn't require interstellar travel. It exists here, in the crushing darkness of our own ocean depths, waiting for us to develop the technology and courage to explore it properly. Close your eyes and imagine standing on the deck of a ship in the middle of the Pacific Ocean on a moonless night. The darkness is absolute, no light pollution, no city glow on the horizon, just you and the infinite black of sea and sky. Then you look down at the water and it's glowing, not reflecting light, but producing it, a ghostly blue-green luminescence that pulses and swirls with every movement of the waves. Fish darting beneath the surface leave trails of light like underwater comets. The ship's wake glows brilliant blue as if you're sailing through liquid starlight. This isn't fantasy or hallucination. It's bioluminescence, one of the ocean's most beautiful and mysterious phenomena. Bioluminescence is the production and emission of light by living organisms through chemical reactions. On land, we're familiar with fireflies and glowworms, but these terrestrial light producers are rare exceptions. In the ocean, bioluminescence is everywhere. Scientists estimate that up to 90% of deep-sea creatures produce light in some form. The ocean's depths, far from being a realm of darkness, are actually filled with biological light shows of extraordinary complexity and beauty. The chemistry behind bioluminescence involves a light-emitting molecule called luciferin and an enzyme called luciferase. When luciferin reacts with oxygen in the presence of luciferase, it produces light with remarkable efficiency, far more efficient than any light bulb humans have invented. This cold light produces almost no heat, meaning nearly all the energy goes into making light rather than being wasted as thermal energy. It's a chemical process so elegant that scientists have borrowed the luciferin luciferase system for use in medical research and biotechnology. Different organisms use bioluminescence for different purposes, creating an underwater ecosystem where light is language, weapon, lure, and camouflage all at once. Some creatures use it for communication, flashing patterns to attract mates or coordinate with others of their species. The Hawaiian bobtail squid hosts colonies of bioluminescent bacteria in a special organ, using their light to eliminate its shadow when viewed from below, a camouflage technique called counterillumination that makes the squid invisible to predators looking up from darker depths. The anglerfish has evolved perhaps the most famous use of bioluminescence. The lure. Female anglerfish have a modified spine that projects forward like a fishing rod, with a glowing tip filled with bioluminescent bacteria. In the absolute darkness of the deep ocean, this light attracts prey fish toward the anglerfish's enormous jaws. The male anglerfish, by contrast, is tiny and doesn't have a lure. He's essentially a parasite that fuses to the female's body, their circulatory systems merging until he's reduced to little more than a sperm-producing appendage. It's a reproductive strategy as alien as anything in science fiction. Some jellyfish produce bioluminescence as a defense mechanism. When disturbed, they flash brilliantly, either startling the attacker or attracting the attention of larger predators who might prey on the attacker. It's called the burglar alarm strategy. You can't fight your attacker, but you can summon someone who might eat them. Certain jellyfish create spectacular light shows when threatened, pulsing with bioluminescent waves that ripple across their bells. The vampire squid, which despite its ominous name isn't actually a threat to humans, has one of the most remarkable bioluminescent displays in the ocean. When threatened, it turns itself inside out, exposing webbing between its arms that's covered in light-producing organs called photophores. These organs can produce disorienting clouds of bioluminescent mucus that glow for up to 10 minutes, creating a distraction while the vampire squid escapes into darkness. The creature can control these photophores individually, creating patterns of light that pulse across its body like programmable LEDs. But perhaps the most mysterious bioluminescent phenomenon isn't produced by animals at all. It's the Milky Sea effect, a rare occurrence where vast areas of ocean surface glow uniformly with a steady, milky light. Sailors have reported milky seas for centuries, describing expanses of glowing water stretching to the horizon in all directions, sometimes covering thousands of square miles. For years, scientists were skeptical of these reports, suspecting exaggeration or misidentification of more common bioluminescent phenomena. Then, in 2005, satellite imagery confirmed what sailors had been reporting. Scientists identified a Milky Sea event off the coast of Somalia that covered approximately 6,000 square miles and lasted for 3 consecutive nights. The light was intense enough to be detected from space, glowing with steady luminescence completely unlike the typical sparkle of disturbed bioluminescent plankton. This wasn't just a few glowing organisms. It was an area of ocean, larger than Connecticut, producing continuous light. The source of Milky Seas appears to be massive blooms of bioluminescent bacteria, likely Vibrio Harvey, which can reach population densities exceeding 100 billion cells per milliliter of seawater. At these extraordinary concentrations, the bacteria produce a steady glow rather than the flashing light of disturbed plankton. What triggers these massive bacterial blooms remains unclear, though they seem to be associated with particular oceanographic conditions, and possibly with algae blooms that provide nutrients for the bacteria. Experiencing a Milky Sea must be surreal. Imagine sailing for hours through water that glows with consistent, eerie light, the waves and swells visible in luminescent detail, the entire ocean transformed into something alien. No sparkles, no flashes, just steady, omnipresent glow stretching as far as you can see. Some sailors describe it as beautiful, others as deeply unsettling. It's a reminder that the ocean can transform into something fundamentally strange, something that seems to belong more to dreams than reality. Dinoflagellates, microscopic plankton, produce the bioluminescence that most people have witnessed firsthand. The sparkles and glowing waves you might see in coastal waters at night, when disturbed by movement. A swimmer's hand, a breaking wave, a boat's wake. These single-celled organisms flash briefly, creating points of blue-green light. The effect is caused by mechanical disturbance triggering a chemical cascade in the dinoflagellate cells. It's a defense mechanism, thought to either startle small predators or attract larger predators who might eat whatever is disturbing the dinoflagellate. Some coastal areas are famous for particularly intense dinoflagellate bioluminescence. The Maldives, Puerto Rico's Mosquito Bay, and parts of California's coast can produce spectacular displays where every wave crashing on shore glows brilliant blue. Swimming in these waters creates a surreal experience. Your body surrounded by swirling light, every movement triggering cascades of sparkles, as if you're moving through liquid stars. Photographers have captured stunning images of these bioluminescent bays, though pictures never quite capture the otherworldly feeling of being immersed in living light. The ecological importance of bioluminescence goes beyond beauty and curiosity. In the deep ocean, where sunlight never penetrates, bioluminescence provides the only light that exists. This means it shapes the entire ecosystem in ways we're only beginning to understand. Predator-prey relationships, mating behaviors, territorial displays, camouflage strategies. All of these are mediated through bioluminescence. The deep ocean isn't dark and silent. It's a realm of communication and interaction happening in wavelengths we can only appreciate through special cameras and sensors. Scientists studying bioluminescence have found that different species produce different colors and patterns of light, creating a complex optical environment. Some species can even see polarized light, adding another dimension to visual communication that humans can't perceive without instruments. The deep sea is essentially having conversations in light, with each species speaking its own dialect, and we're only beginning to learn how to listen. Research into bioluminescence has practical applications beyond understanding ocean ecosystems. The luciferin-luciferase reaction is used as a marker in medical research, allowing scientists to track specific cells or proteins that have been genetically modified to produce light. This technique has applications in cancer research, drug development, and understanding cellular processes. The green fluorescent protein originally discovered in jellyfish has become one of the most important tools in modern biology, earning its discoverers a Nobel Prize. There's also growing interest in using bioluminescence for sustainable lighting. While we haven't yet developed practical bioluminescent streetlights, researchers are exploring whether modified organisms or synthetic biology could create living lighting solutions that don't require electricity. The idea of trees that glow softly at night or architectural bioluminescence that grows rather than being manufactured represents a fascinating intersection of biology and technology. The bioluminescent phenomena of the ocean remind us that light isn't just something that comes from the sun or from human technology. Life itself can be a source of light, can sculpt light into signals and patterns, can paint the darkness with living color. In the deep ocean, where no human existed for billions of years, and where the sun's rays never reach, life invented its own illumination. It's a powerful reminder that life is creative, adaptive, and capable of finding solutions to challenges we might think insurmountable. In June 2011, a Swedish treasure hunting team called Ocean X was conducting sonar surveys of the northern Baltic Sea floor, searching for valuable shipwrecks in the waters between Sweden and Finland. The Baltic is full of historical wrecks. Centuries of maritime trade and warfare have left the seabed littered with sunken vessels that sometimes contain valuable cargo. The team, led by Peter Lindberg and Dennis Berg, was methodically scanning the seabed when their sonar detected something unusual at a depth of about 300 feet. The sonar image showed a circular object approximately 200 feet in diameter resting on the ocean floor. But it wasn't the size that captured attention. It was the shape. The object appeared to be a thick, circular disc with unusual features. The sonar image showed what looked like straight lines, right angles, and a ramp or stairway leading up to the object. There also appeared to be a long drag trail behind the object, suggesting it had skidded across the seabed before coming to rest in its current location. When OceanX released the sonar images to the media, the response was immediate and intense. The object looked, to many observers, exactly like the Millennium Falcon from Star Wars, a circular craft with what appeared to be structural features too regular to be natural. UFO enthusiasts immediately claimed this was evidence of an ancient alien craft that had crashed into the Baltic Sea. The term Baltic Sea Anomaly was coined, and the object became one of the most discussed underwater mysteries of the 21st century. OceanX planned a return expedition to investigate the object more closely. They assembled a team including divers and documentary filmmakers, secured funding, and returned to the site in 2012. The team reported several strange occurrences during this expedition. They claimed that electronic equipment malfunctioned when directly over the object. Satellite phones stopped working, their sonar equipment behaved erratically, and electrical systems on their boat experienced problems. When they moved away from the site, the equipment reportedly functioned normally again. Divers who descended to the object brought back even more intriguing reports. They described the object as having unnaturally smooth surfaces and perfect right angles, features that seemed incompatible with natural geological formations. One diver compared it to standing at the top of a stairway leading down into the object. They reported seeing what appeared to be burn marks or scorch patterns on the surfaces. Samples were collected from the object's surface for analysis. The samples added to the mystery rather than resolving it. Analysis showed the object consisted primarily of basalt, a volcanic rock, but with unusual composition, including high levels of metals like iron and other elements not typically found in Baltic seabed geology. Some analysts claim to have found traces of materials that shouldn't exist in natural rock formations. Others pointed to unusual structures in the samples that they couldn't easily explain. The electrical interference reports seemed to support the idea that the object was something technological rather than geological. How could a rock formation cause electronic equipment to malfunction? Some speculated about residual radiation or electromagnetic fields from ancient technology. Others suggested the object might be part of a Nazi anti-submarine device from World War II. The Baltic was heavily militarized during the war, and various experimental technologies were tested and deployed in these waters. The mainstream media picked up the story, and it appeared in documentaries and news programs worldwide. The mysterious object in the Baltic became a touchstone for discussions about underwater archaeology, unexplained phenomena, and the possibility of ancient advanced civilizations or alien visitors. Tourism to the region increased as people became fascinated by the mystery, occurring in the relatively accessible Baltic waters. But as often happens with sensational claims, skeptical investigation revealed a more prosaic reality. Multiple geologists and oceanographers examined the evidence, and their conclusions were consistent. The Baltic Sea Anomaly was almost certainly a natural geological formation, specifically a glacial deposit. The Baltic region was covered by massive ice sheets during the last ice age, which ended approximately 10,000 years ago. As these glaciers moved across the landscape, they picked up rocks and sediment, carrying this material embedded in the ice. When the glaciers melted, they deposited this material in complex formations that can look remarkably artificial to the untrained eye. Glacial deposits frequently show features that seem too regular to be natural. Straight edges where different sediment layers meet, flat surfaces created by glacial grinding, and angular formations where ice-transported boulders settled in particular arrangements. The ramp or stairway that divers reported could easily be stratified layers of sediment and rock deposited by glacial action. The circular shape might be a coincidental arrangement or might relate to how the glacial deposits settled onto the underlying seabed. The drag trail behind the object also has a geological explanation. As the glacier melted, massive amounts of material were transported by meltwater and settled onto the seabed. The trail could represent the path along which sediment and debris flowed before the main mass of the deposit came to rest. Alternatively, it could be a moraine, a ridge of glacial debris, that happens to align with the larger formation. As for the electrical interference, skeptics point out several problems with these reports. First, they're anecdotal and weren't documented with proper scientific controls. Second, the Baltic Sea has complex electromagnetic properties due to its unusual salinity gradients and geological features. Third, equipment malfunctions are common in marine environments due to saltwater exposure, temperature changes, and the rigors of operating electronics in harsh conditions. Fourth, and perhaps most damningly, other vessels that have visited the site since haven't reported similar problems. The sample analysis also became controversial. Independent geologists who examined the samples found nothing particularly unusual. The composition was consistent with basaltic rock that had been transported and deposited by glacial action. The metals present occur naturally in basalt. The structures that some analysts found unusual were consistent with common geological processes. The earlier sensational reports of unknown materials appear to have been either misinterpretations or exaggerations. Volcanologists pointed out that the Baltic region has a complex geological history that includes volcanic activity, though not recent. Basaltic rock formations exist in the region, and glaciers certainly would have transported such rocks and deposited them in the Baltic seabed. There's nothing about the anomaly that requires technological explanation. Everything observed can be explained through known geological processes. The comparison to the Millennium Falcon, while attention-grabbing, relies on the low resolution of sonar imagery and the human tendency to perceive familiar patterns in ambiguous stimuli. The same psychological phenomenon that makes us see faces in clouds or Jesus in toast. Higher resolution, sonar images of the site show a less dramatic structure that bears less resemblance to spacecraft and more to typical glacial deposits. Ocean X themselves, despite initial sensational claims, gradually backed away from the most extreme interpretations. They acknowledged that the object might be a natural formation, while maintaining that it was unusual and worthy of further study. The team had financial incentives to keep the mystery alive. They were selling documentary rights and attracting funding for expeditions. But they stopped short of claiming definitively that they'd found alien technology. The Baltic Sea Anomaly story reveals several interesting aspects of how modern mysteries develop and spread. First, sonar imagery is easily misinterpreted by non-experts, creating ambiguous evidence that can support multiple interpretations. Second, the combination of unusual appearance and electronic equipment problems creates a compelling narrative that's hard to resist, even when each element has prosaic explanations. Third, the media's appetite for sensational stories can amplify weak evidence and give fringe theories far more attention than they deserve. Most importantly, the story demonstrates how human psychology interacts with ambiguous evidence. We want there to be mysteries. We want to discover something unprecedented. When we encounter something unusual, our imaginations immediately jump to the most exciting possibilities rather than the most likely ones. A glacial deposit, no matter how unusually shaped, isn't as exciting as an ancient alien spacecraft or Nazi superweapon. The Baltic Sea anomaly isn't evidence of aliens or ancient advanced technology. It's a geological formation that happens to have an interesting shape. But the enthusiasm with which people embraced the mystery, the speed with which it spread across social media and news outlets, and the persistence of belief in its unusual nature despite geological explanations. These things tell us something about human nature and our relationship with the unknown. We want the ocean to hold secrets. We want there to be discoveries that upend our understanding of history and possibility. And sometimes, we want that so badly that we see spacecraft in glacial deposits, technology in basalt, and ancient mysteries in geological processes that are well understood by scientists, but unfamiliar to the public. The Baltic Sea anomaly is less interesting for what it is than for what it reveals about us. In the warm seas of the Miocene epoch, approximately 23 to 3.6 million years ago, the oceans were ruled by the largest predatory shark that ever lived. Megalodon, the name literally means big tooth, was a creature of such massive proportions that it makes the modern great white shark look modest by comparison. Estimates based on fossil evidence suggest Megalodon reached lengths of 50 to 60 feet, with some researchers proposing even larger maximum sizes. This was a shark that could swallow an adult human whole, that preyed on whales, that had teeth the size of human hands. Those teeth are almost the only fossil evidence we have of Megalodon. Like all sharks, Megalodon's skeleton was made of cartilage rather than bone, which rarely fossilizes. But teeth. Teeth are hard, mineral-rich structures that preserve beautifully. Megalodon teeth are found in marine deposits worldwide, and they're unmistakable. Each tooth can measure up to 7 inches in length. Triangular, serrated, designed for cutting through flesh and bone with devastating efficiency. Fossil hunters prize these teeth, and complete specimens can sell for thousands of dollars. From these teeth and the occasional vertebrae that manage to fossilize, scientists have reconstructed what Megalodon looked like and how it lived. The most reliable method involves comparing Megalodon teeth to those of its closest living relative, the great white shark, and scaling up proportionally. This suggests a shark with a massive, stocky body, enormous jaws capable of opening to nearly 10 feet wide, and a bite force estimated at up to 40,000 pounds per square inch, several times stronger than a Tyrannosaurus rex. Megalodon was an apex predator in the truest sense. Fossil evidence shows bite marks on whale bones that match Megalodon teeth perfectly. The shark apparently targeted large marine mammals, using its enormous size and powerful bite to disable prey before feeding. Some fossil whale bones show evidence of Megalodon attacks that the whale survived. Massive bite marks that healed, suggesting that even a non-fatal encounter with Megalodon was a traumatic event that left permanent scars. The shark disappeared from the fossil record approximately 3.6 million years ago, and scientists have developed several theories about why such a successful predator went extinct. One leading theory involves climate change. The Pliocene epoch saw significant cooling of ocean temperatures and changes in ocean circulation patterns. Megalodon, being such a large animal, required enormous amounts of food and warm waters where prey was abundant. As oceans cooled and prey distributions changed, Megalodon may have been unable to adapt quickly enough. Another theory focuses on competition. The Pliocene saw the rise of orcas and other toothed whales that hunted in cooperative groups. These social predators might have outcompeted Megalodon for food sources. Additionally, baleen whale species that Megalodon likely preyed upon were evolving to be faster swimmers, making them harder to catch. The combination of climate change, increased competition, and changing prey behavior may have pushed Megalodon to extinction. There's also evidence that changes in ocean currents disrupted nursery areas where juvenile Megalodon would have grown. Young Megalodon needed protected, food-rich environments to mature before they could hunt in open ocean. If these nursery areas disappeared or became less productive due to changing ocean conditions, Megalodon reproduction would have been severely impacted, leading eventually to extinction. All scientific evidence points to Megalodon being extinct for millions of years. The absence of recent Megalodon teeth in ocean sediments, the lack of any physical evidence of living specimens, and the ecological unlikelihood of such a large predator remaining undiscovered all support the conclusion that this magnificent shark is gone. Yet despite clear scientific consensus, a persistent belief remains that Megalodon might still swim in the ocean's depths, particularly in the deep trenches we've barely explored. This belief in surviving Megalodon has become a cultural phenomenon, spawning documentaries, movies, books, and endless internet speculation. The arguments for Megalodon's continued existence typically follow similar patterns. The ocean is mostly unexplored. Large sharks occasionally appear that don't match known species, and wouldn't it be amazing if such a creature still existed? These arguments appeal to our desire for mystery and our fascination with apex predators, but they don't withstand scientific scrutiny. The unexplored ocean argument is technically true but misleading. Yes, we haven't physically visited most of the ocean floor, but we have extensive data from surface observations, satellite monitoring, fishing operations, naval activities, and marine research. A 50-foot shark couldn't hide from these observation systems. Megalodon wasn't a deep-sea creature. It was a warm-water coastal predator that hunted near the surface where large marine mammals were abundant. It would be regularly seen, photographed, and encountered by the millions of people who work on or in the ocean. Some point to occasional sightings of unusually large sharks as potential Megalodon evidence. In reality, these sightings almost always turn out to be large great white sharks, whale sharks, or basking sharks seen under conditions that made size estimation difficult. Great white sharks can reach 20 feet in length, and when seen briefly in murky water or from a distance, they can appear much larger than they are. Whale sharks, which can exceed 40 feet, are gentle filter feeders, but when seen partially or from an angle that obscures their distinctive markings, they might be misidentified as predatory sharks. The Discovery Channel's 2013 Megalodon. The Monster Shark Lives mockumentary demonstrates how powerful the desire to believe in surviving Megalodon can be. The program was presented as factual documentation of Megalodon evidence, complete with fake scientists and fabricated footage, only revealing in small print during credits that it was fictional entertainment. Despite this disclosure, many viewers believed it was real, and the program sparked renewed interest in Megalodon survival theories. The network was criticized for blurring the line between science and fiction, but the program's success showed how compelling the idea of living Megalodon remains. The fundamental problem with Megalodon survival theories is ecological, not just evidential. A breeding population of 50-foot sharks would have enormous environmental impact. They would need to hunt large prey regularly. The ocean's whale populations, which have been extensively studied and monitored, show no evidence of predation from a Megalodon-sized predator. Whale carcasses occasionally wash ashore, and their injuries are well documented. Orca attacks, ship strikes, entanglement in fishing gear. There are no wounds consistent with Megalodon bites, no missing whales that would suggest predation by a massive shark. Additionally, Megalodon would need warm, shallow waters for reproduction and juvenile development, just as modern sharks do. These are exactly the areas most heavily monitored by humans. The idea that breeding populations of giant sharks could exist in coastal waters, without ever being definitively documented, strains credibility beyond the breaking point. The fascination with Megalodon surviving reveals something deeper than just interest in sharks. It represents our desire for the world to still contain megafauna, for there to be creatures of legendary scale still swimming in the oceans. We've driven so many large animals to extinction or near extinction in recent centuries. The prospect of a massive predator thriving beyond human reach appeals to something primal. It suggests that nature still has secrets, that human impact on the planet isn't total, that wilderness still exists beyond our control and knowledge. The cultural persistence of Megalodon also reflects our complicated relationship with sharks in general. These animals fascinate and terrify us in equal measure. The shark as monster has been a staple of human storytelling since we first ventured onto the sea, and Megalodon represents the ultimate expression of this archetype, a shark so large that it becomes almost mythological in scale. Movies like The Meg, books, video games, and endless internet content about Megalodon feed our appetite for shark horror while knowing we're safe from actual threat. Ironically, the extinction of Megalodon allows us to be fascinated by it without fear. We can imagine encounters with this magnificent predator without worrying about actual danger. This makes Megalodon more appealing as a subject of speculation than dangerous living sharks that actually pose minimal threat to humans, but generate disproportionate fear. The fantasy of Megalodon is safer than the reality of great white sharks because we know Megalodon is gone, except in our imaginations where we can control the narrative. The truth is that Megalodon, in its actual lived reality, was far more interesting than any fantasy of surviving populations. This was an animal that represented the pinnacle of shark evolution, that shaped marine ecosystems for millions of years, that witnessed the evolution of whales from land mammals back into ocean dwellers, and then developed the capability to hunt them. The story of its success and eventual extinction tells us about how Earth's climate and ecosystems have changed, about how even the most dominant predators can disappear when conditions shift, about how the world we inhabit today is radically different from the world of the Pliocene epoch. Megalodon is gone, and that's okay. Its extinction doesn't make it less remarkable. The ocean today hosts wonders that would have amazed our ancestors. Great white sharks, orcas, sperm whales diving to crushing depths to hunt giant squid, ecosystems of extraordinary complexity and beauty. We don't need Megalodon to be alive for the ocean to be full of wonder. The real creatures swimming in our oceans right now are extraordinary enough. If you've flown over or sailed through the western Atlantic Ocean between Miami, Bermuda, and Puerto Rico, congratulations. You've traversed the Bermuda Triangle and lived to tell about it. So have millions of other people who travel through this heavily trafficked region every year without incident. Yet for decades, this roughly triangular area of ocean has been associated with mysterious disappearances of ships and aircraft, spawning countless books, documentaries, and theories about everything from magnetic anomalies to alien abductions to portals to other dimensions. The Bermuda Triangle legend, as we know it today, was largely created by Charles Berlitz in his 1974 best-selling book, The Bermuda Triangle. Berlitz compiled reports of disappearances in the region dating back to the mid-19th century and presented them as evidence of a localized zone of supernatural danger. He suggested various exotic explanations, from the lost city of Atlantis still generating energy from ancient technology, to UFO activity, to time warps that transported vessels into other dimensions. The book sold millions of copies and cemented the Bermuda Triangle in popular consciousness as a place of mystery and danger. But the Bermuda Triangle's reputation doesn't hold up to scrutiny. The U.S. Coast Guard, which presumably would notice if a particular region experienced unusually high numbers of disappearances, states plainly that the number of incidents in the Bermuda Triangle is not significantly higher than in any other heavily traveled section of ocean. The area sees enormous amounts of commercial shipping, private boating, and air traffic, so accidents do occur, but at rates consistent with the volume of traffic and the region's weather conditions. Many of the disappearances Berlitz and other writers attributed to the Bermuda Triangle didn't actually occur there. happened under circumstances later explained, or were embellished with fictional details. The famous case of Flight 19, 5 Navy bombers that disappeared in 1945, is often cited as the quintessential Bermuda Triangle mystery. In reality, the flight leader was inexperienced with the area, became disoriented, and led the formation in the wrong direction. Radio communications show increasing confusion and poor decision-making. The aircraft likely ran out of fuel and crashed into the ocean in rough weather. It's a tragedy, but not a supernatural mystery. The disappearance of the USS Cyclops in 1918, with 306 crew members aboard, is another frequently cited case. The cargo ship vanished without sending distress signals while sailing from Barbados to Baltimore. Various exotic theories have been proposed, but the most likely explanation involves structural failure. The Cyclops was overloaded with heavy manganese ore, had one engine inoperable, and sailed into a severe storm. Similar cargo ships from the same era suffered catastrophic structural failures due to overloading, and the Cyclops likely broke apart and sank rapidly, too quickly for distress signals. However, setting aside the supernatural explanations, the Bermuda Triangle region does have some genuine oceanographic and meteorological features that make it potentially hazardous for navigation. Understanding these actual characteristics reveals a more interesting story than tales of alien abduction. It shows how natural processes can create genuinely dangerous conditions that might seem mysterious to observers lacking scientific context. One of the most significant features is the Gulf Stream, a powerful ocean current that flows through the region. The Gulf Stream can reach speeds of 5.6 miles per hour, which is fast enough to significantly affect navigation. Ships or debris from accidents can be rapidly carried away from their last known positions, making search and recovery operations extremely difficult. Additionally, the Gulf Stream can cause rapid and unpredictable changes in local weather conditions, creating storms with little warning. The region is also prone to sudden severe weather. The Bermuda Triangle lies in a zone where cold fronts from North America collide with warm tropical air, creating ideal conditions for intense storms. Waterspouts, essentially tornadoes over water, are common in the area. These rotating columns of air and water can appear suddenly and are extremely dangerous to small aircraft flying at low altitude. Large waterspouts can also threaten ships, particularly smaller vessels. The bathymetry, the underwater topography, of the Bermuda Triangle region is complex and includes some of the deepest water in the Atlantic Ocean. The Puerto Rico Trench, which borders the triangle, reaches depths of over 28,000 feet. Objects that sink in these deep areas would be extraordinarily difficult to locate and recover. This partially explains why some vessels have disappeared without trace. They're resting in deep water, where conventional search methods are ineffective. One of the most scientifically interesting features of the region involves methane hydrate deposits on the ocean floor. Methane hydrates are crystalline structures where methane gas is trapped in a lattice of water molecules. These deposits exist in a stable state under specific conditions of cold temperature and high pressure. However, if something destabilizes these deposits, changes in ocean temperature, seismic activity, or shifting sediment, they can release massive amounts of methane gas into the water column. Large releases of methane gas could theoretically pose danger to ships. Methane bubbles rising through water dramatically reduce the water's density. If a ship is floating over an area where large amounts of methane suddenly bubble up, the decreased water density could cause the ship to sink rapidly. Additionally, methane gas reaching the surface could create a fog of flammable gas that might ignite from engine exhaust or electrical systems, potentially explaining some reports of vessels that appeared to catch fire before sinking. Scientists have found evidence of massive methane release events in the geological record, including in the Atlantic Ocean. Some underwater craters on the ocean floor appear to have been created by methane eruptions. While no documented case clearly links methane release to a specific Bermuda Triangle disappearance, the theoretical possibility exists, and research continues into how methane hydrates might affect surface vessels. Magnetic anomalies in the region have also been proposed as explanations for navigational problems. The Bermuda Triangle is one of the few places on Earth where true north and magnetic north align, which could potentially cause confusion for navigators using magnetic compasses if they're not aware of this peculiarity. However, modern navigation relies primarily on GPS and other electronic systems rather than magnetic compasses, making this less relevant than it might have been in earlier eras. Electronic equipment malfunctions have been reported in the region, though not at rates higher than other areas. Some reports describe compass spinning wildly or electronic systems failing. Skeptics point out that the Caribbean region has high humidity and salt air that can damage electronics, and that equipment failures are common in marine environments regardless of location. The attribution of these failures to mysterious Bermuda Triangle properties likely reflects confirmation bias rather than genuine anomalies. Underwater archaeology in the Bermuda Triangle region has revealed something less sensational than lost civilizations, but perhaps more historically significant. Hundreds of shipwrecks from centuries of maritime activity. The region has been a major shipping route since European colonization of the Americas, and countless vessels have been lost to storms, reefs, navigational errors, and warfare. These wrecks tell stories of Caribbean piracy, colonial trade, naval battles, and the constant human struggle against the sea's dangers. Some of these wrecks have been located and identified, solving mysteries about specific disappearances. Others remain undiscovered, their locations forgotten or obscured by time and shifting sediments. The concentration of wrecks in some areas of the triangle isn't evidence of supernatural dangers. It's evidence of shallow reefs, narrow passages, and historical shipping routes where accidents were more likely to occur. The Bermuda Triangle legend persists partly because it's become self-reinforcing. Any incident in the region gets attributed to the triangle's mysterious properties, while similar incidents elsewhere are treated as routine accidents. Media coverage emphasizes the mysterious aspects while downplaying prosaic explanations. Popular culture has so thoroughly established the Bermuda Triangle as a mysterious place that each generation rediscovers it and is fascinated anew. The truth is less exotic but more interesting. The Bermuda Triangle is a busy section of ocean with complex weather patterns, strong currents, deep water, and heavy traffic. Accidents happen there for the same reasons they happen anywhere: human error, equipment failure, severe weather, and the fundamental unpredictability of the sea. The ocean doesn't need supernatural properties to be dangerous. Its natural characteristics are formidable enough. In the early 2000s, strange stories began circulating on Japanese internet forums, particularly on 2channel, Japan's largest online community. Crew members on Japanese government whale research vessels operating in Antarctic waters reported encountering something extraordinary. Massive, pale humanoid figures swimming near their ships in the frigid Southern Ocean. These creatures, which came to be called Ningen, the Japanese word for human, were described as being 20 to 30 meters long, completely white or pale gray, with smooth skin resembling that of whales or dolphins. But unlike any known whale, these creatures appeared to have distinctly humanoid features. Arms or flippers with fingers, legs or tail flukes that moved vertically rather than horizontally, and most unsettling, faces that resembled human features in their arrangement. The descriptions varied in details, but common elements emerged from multiple alleged sightings. Witnesses described enormous pale forms that would surface near vessels, sometimes following ships for periods before submerging and disappearing. Some reports included photographic or video evidence, though these images were typically blurry, taken at night or in poor weather conditions, showing indistinct white shapes in dark water. The creatures were said to be shy, avoiding close approach, but occasionally observed from a distance. Some accounts described the Ningen as having 5-fingered hands at the ends of arm-like appendages. Others reported seeing what appeared to be eyes and a mouth arranged in a face-like configuration on what would be the creature's head. The overall impression, according to these reports, was deeply unsettling. Something that resembled a human but at a scale, and in a form that clearly wasn't human, moving with purpose through Antarctic waters where no human could survive unprotected. The Ningen legend spread through Japanese internet culture, evolving and elaborating as such stories do. Artists created illustrations based on the descriptions, depicting smooth, pale beings that resembled a cross between humans and whales. Some images showed them with distinctly humanoid faces, others emphasized their alien strangeness. The creature became a fixture of Japanese cryptozoology and internet folklore, discussed alongside more traditional mysterious creatures, but with a modern, digital age flavor to its propagation. The timing of the Ningen's emergence is significant. The stories began circulating during a period when Japanese whaling operations in Antarctic waters were facing increasing international criticism. Japan's whale research program, which involved killing whales for what Japan claimed was scientific research, was controversial globally, and environmental groups were actively protesting and interfering with whaling operations. Some observers have suggested that the Ningen legend might have been created as a distraction, a way to generate alternative narratives about what Japanese vessels were doing in Antarctic waters, or perhaps as an in-joke among crew members that escaped into wider circulation. From a cryptozoological perspective, several known animals could potentially explain Ningen sightings, particularly when observed under poor conditions by startled witnesses. Beluga whales, though not typically found in Antarctic waters, are extremely pale and have flexible necks that can make their head movements seem surprisingly humanoid. Their melon, the rounded forehead structure, can appear face-like under certain lighting conditions. However, belugas don't reach anywhere near the size reported for Ningen, and their distribution doesn't match the reported sighting locations. Antarctic minke whales, which are found in the Southern Ocean where Ningen are supposedly encountered, could potentially be misidentified under certain circumstances. When seen partially surfacing or from unusual angles, particularly at night or in poor weather, the smooth contours of a whale's body might create impressions of humanoid features that don't actually exist. The human brain is exceptionally good at finding faces in ambiguous stimuli, a phenomenon called pareidolia, and whale anatomy viewed from certain angles might trigger this pattern recognition. Leopard seals, which can grow to 11 feet long and have distinctly reptilian heads, are another potential explanation for some sightings. These formidable predators patrol Antarctic waters and occasionally approach vessels. Their coloring can appear pale in certain lighting, and their aggressive behavior might make encounters particularly memorable. However, they're far too small to account for the massive scale reported in Ningen descriptions. The most likely explanation for the Ningen legend, however, isn't misidentification of known animals, but rather the phenomenon of modern folklore creation through internet culture. The Ningen appears to be a digital age cryptid, a creature born not from centuries of accumulated folklore, but from internet forums, Photoshop, and the rapid spread of information through online networks. This doesn't make it less interesting from a cultural perspective. It makes it a fascinating example of how modern technology changes how legends develop and spread. Traditional cryptids like Bigfoot or the Loch Ness Monster evolved over generations, their characteristics solidifying through repeated retelling until a consistent description emerged. The Ningen's development was compressed into just a few years of internet discussion. Artists' interpretations influenced subsequent reports, with people describing features that had been imagined in illustrations rather than observed in nature. The feedback loop between image creation and testimony shows how digital media can rapidly codify and standardize a legend. The creature also reflects distinctly Japanese aesthetic and narrative sensibilities. Japan has a long tradition of yokai, supernatural entities that occupy an ambiguous space between natural and supernatural, often associated with specific locations or phenomena. The Ningen fits comfortably within this tradition while being adapted to modern contexts. Instead of haunting forests or rivers, it inhabits the remote Antarctic seas that Japanese vessels operate in. It's a yokai for the age of oceanographic research and industrial whaling. There's also something poignant about the Ningen legend emerging in the context of whaling operations. These stories describe something vast, mysterious, and vaguely human encountered in waters where humans are killing whales. Whether intentional or not, the Ningen could be read as a manifestation of guilt or unease about human actions in the Antarctic, a symbolic representation of the ocean watching us, of something that resembles us inhabiting waters we venture into as intruders. The lack of credible evidence for Ningen is striking given the circumstances of supposed encounters. Japanese research vessels are equipped with sophisticated imaging equipment, sonar, and cameras. Crew members carry personal cameras and smartphones. Yet no clear photograph or video of a Ningen has emerged. The images that circulate online are consistently ambiguous, distant, blurry, interpretable as ice formations, waves, or known animals, as easily as they're interpretable as mysterious humanoids. This absence of evidence is particularly significant because Antarctic waters are relatively well monitored. Multiple nations maintain research stations and operate vessels in the region. Satellite imagery covers the area. If 20 to 30 meter creatures were regularly present, they would be detected by multiple observation systems. The Southern Ocean, while remote and harsh, isn't unknown or unexplored in the way that deep oceanic trenches are. The Ningen does, however, highlight a genuine feature of Antarctic waters. They're home to creatures that are genuinely strange and poorly understood. Colossal squid live in these waters, as do numerous species adapted to extreme cold. The Antarctic cod has antifreeze proteins in its blood that prevent ice crystals from forming in its tissues. Sea spiders grow to enormous sizes. The waters beneath Antarctic ice shelves host ecosystems we're only beginning to discover. While the Ningen itself likely doesn't exist, the waters it supposedly inhabits genuinely are filled with remarkable life. The legend also points to the psychological impact of working in Antarctic waters. The Southern Ocean is one of Earth's most hostile marine environments. Crew members on research vessels spend months in extreme cold, dealing with dangerous weather in near-constant daylight during summer or extended darkness during winter. These conditions can produce psychological stress, fatigue, and perceptual distortions. Reports of unusual sightings might reflect the mental strain of working in such an environment as much as anything actually in the water. From a folklore perspective, the Ningen is interesting precisely because of its modernity. It demonstrates that cryptid legends don't require centuries to develop. They can emerge fully formed in just a few years, given the right cultural and technological context. The creature shows how internet culture can generate and propagate legends with unprecedented speed, creating within years what would have taken generations in earlier eras. The Ningen also reveals our continuing desire for mystery, even in an age of satellites and GPS, when it seems like every corner of Earth should be mapped and understood. We want there to be unknown creatures, places where mystery persists, encounters that challenge our understanding of what exists. The fact that this particular mystery probably doesn't exist doesn't eliminate that desire. It just means we'll keep looking, Keep interpreting ambiguous experiences as potentially significant. Keep telling stories about what might be out there in waters we rarely visit. Whether the Ningen is real is less interesting than what the legend tells us about contemporary Japanese culture, about how internet forums create and spread folklore, and about our persistent need to populate remote places with mysterious beings. The Ningen is a creature of the digital age, born in forum posts and Photoshop files, a humanoid presence in inhuman waters, watching Japanese vessels from the depths of the Antarctic Sea. Real or not, it's a fascinating addition to the catalog of creatures humans have imagined swimming in Earth's oceans. Imagine you're observing the ocean floor at a depth of 6,000 feet through the camera of a remotely operated vehicle. The landscape is dark, cold, and seemingly barren, just fine sediment stretching in all directions. Then something moves at the edge of your camera's light. It's an isopod, a creature that looks like an enormous roly-poly or pill bug. But this isn't the tiny isopod you might find under a rock in your garden. This specimen is over a foot long, with armored plates and multiple legs, looking like something that crawled out of a science fiction movie. This is Bathynomus giganteus, the giant isopod, and it's just one example of a phenomenon that has fascinated marine biologists for decades. Deep-sea gigantism. Deep-sea gigantism refers to the tendency of certain animal groups to grow much larger at great depths than their shallow-water relatives. The effect is particularly pronounced in crustaceans, but it appears in other groups as well. Giant isopods can reach 20 inches in length compared to the half-inch typical of shallow-water species. Giant amphipods in deep ocean trenches grow to nearly a foot long, while their coastal cousins are typically less than an inch. Deep-sea squids, as we've discussed, dwarf their shallow-water relatives. Sea spiders at abyssal depths can have leg spans exceeding 2 feet, while shallow-water sea spiders rarely exceed an inch. The question is, why? What is it about the deep ocean environment that favors such extreme size? The answer isn't simple. It involves multiple factors that interact in complex ways, creating conditions where gigantism becomes an evolutionary advantage. One factor is temperature. The deep ocean is cold, typically between 30 and 39 degrees Fahrenheit. Cold water slows metabolic rates, which means animals burn energy more slowly. This reduced metabolism allows for slower growth over longer lifespans. In shallow tropical waters, organisms face pressure to grow quickly, reproduce, and die because warm water ecosystems are so competitive and fast-paced. In the cold deep sea, the pace of life slows dramatically. Animals can afford to grow larger over decades rather than reaching maturity in months or years. The cold also relates to oxygen availability. Cold water holds more dissolved oxygen than warm water, which means deep-sea creatures have access to abundant oxygen despite the dark, food-scarce environment. Higher oxygen availability can support larger body sizes because bigger bodies require more oxygen for metabolic processes. This is the same principle that explains why insects were much larger during the Carboniferous period, when atmospheric oxygen levels were higher than today. Pressure is another factor. The deep ocean is a high-pressure environment. At 6,000 feet, the pressure is approximately 170 times that at sea level. While this extreme pressure creates challenges for organisms, it also has stabilizing effects on proteins and cellular structures. Some researchers have suggested that high pressure might allow proteins to function more efficiently in ways that support larger body sizes, though this remains an area of active research. Food scarcity in the deep ocean creates a paradoxical relationship with size. At first glance, you might expect food scarcity to select for smaller body sizes. Less food should mean smaller animals, right? But in environments where food is scarce and unpredictable, arriving in rare large quantities, bigger body size becomes advantageous. Larger animals can consume more food when it's available and store it as energy reserves to survive long periods of scarcity. They're also more efficient at locating food across large areas. The deep ocean receives its food primarily through marine snow, the constant rain of organic debris from the productive surface waters. This food source is diffuse and unreliable, but when something large dies and sinks, a whale, a large fish, a seal, it represents a massive, concentrated food resource. These food falls can sustain entire ecosystems for months. Larger scavengers are better positioned to take advantage of food falls because they can travel farther to locate them, consume more when they arrive, and outcompete smaller organisms for access. In the case of giant isopods, their large size allows them to go for years without eating. Specimens kept in aquariums have survived over 5 years without food, living off stored energy reserves. This extraordinary ability to fast makes sense in an environment where meals are extremely irregular. A small organism that needs to eat frequently would be at a severe disadvantage in the deep sea, while a large organism that can gorge when food is available and then fast for extended periods thrives. Predation pressure also plays a role. In shallow waters, there are numerous predators of all sizes, creating constant selection pressure against growing too large, which would make animals conspicuous and slow. In the deep sea, predators are less abundant, and the darkness provides some protection from visual predators. The reduced predation pressure means the costs of large size, being easier to see, requiring more food, being slower, are less significant, while the benefits, being able to capture larger prey, store more energy, survive longer without food, become more pronounced. Kleber's law, which describes how metabolic rate scales with body size, may also contribute to deep-sea gigantism. Larger animals have lower mass-specific metabolic rates. A pound of elephant tissue burns less energy than a pound of mouse tissue. In the food-scarce deep ocean, this metabolic efficiency could be crucial. A large deep-sea organism needs less food per unit of body mass than a small organism, making large size advantageous when food is scarce. The phenomenon isn't universal, though. Not all deep-sea organisms are giants. Many deep-sea fish are actually quite small, using minimal energy and specialized feeding strategies to survive. The gigantism effect is strongest in invertebrates, particularly crustaceans and cephalopods, and seems to relate to specific ecological niches and feeding strategies, rather than being a universal response to deep-sea conditions. Giant squid and colossal squid exemplify how multiple factors combine to enable extreme size. These creatures are active predators in the deep ocean, hunting fish and other squid in the darkness. Their large size allows them to capture substantial prey, which provides the energy needed to sustain their active lifestyle. Their eyes, the largest in the animal kingdom, gather what little light exists at depth and can detect the bioluminescence of prey or the silhouettes of animals swimming above them. They live in cold waters where their metabolic rates are reduced. They face limited predation except from sperm whales, which are themselves giants. All these factors combine to make extreme size not just possible, but advantageous. The giant tube worms found at hydrothermal vents in the deep ocean represent a different kind of gigantism. These creatures, which can grow to 8 feet long, don't fit the typical pattern because they live in relatively food-rich environments around volcanic vents. Their gigantism relates to a different set of factors. They host chemosynthetic bacteria that produce energy from chemicals in the vent water. They grow continuously throughout their lives, and they can live for over 250 years. Their size reflects their longevity, more than adaptation to food scarcity. Sea spiders, which aren't actually spiders, but belong to a separate arthropod group called pycnogonids, show perhaps the most extreme size increase with depth. Shallow water sea spiders are tiny creatures, rarely exceeding half an inch. Deep sea species can have leg spans exceeding 2 feet. Their gigantism might relate to oxygen absorption. Sea spiders lack respiratory and circulatory systems, instead absorbing oxygen directly through their body surfaces and relying on diffusion to transport it. In the cold, oxygen-rich deep ocean, this primitive system can support much larger body sizes than would be possible in warmer, lower oxygen shallow waters. The study of deep-sea gigantism has practical implications beyond satisfying curiosity about strange creatures. Understanding how these organisms adapt to extreme conditions informs our thinking about where and how life might exist on other worlds. If life has evolved in the subsurface oceans of Europa or Enceladus, it might face similar conditions to Earth's deep ocean. Darkness, cold, limited food, high pressure. The adaptations we see in deep-sea giants might preview the kinds of solutions alien life would evolve to similar challenges. Deep-sea gigantism also challenges assumptions about what environments can support large, complex life. For decades, biologists assumed that large animals required productive environments with abundant food. The discovery that some of Earth's largest invertebrates live in the least productive ocean environments forced a rethinking of these assumptions. Size isn't just about food availability. It's about how organisms use time, energy, and ecological opportunities in their specific environments. The giants of the deep ocean remain difficult to study. Many are known from only a few specimens. Their behavior in natural environments is largely unknown because reaching their habitats requires expensive equipment and expeditions. We're still discovering new species and new examples of gigantism. As technology improves and deep-sea exploration becomes more feasible, we'll likely find even more remarkable examples of this phenomenon. Here's a statistic that should surprise you. We've explored less than 5% of Earth's oceans. We've mapped approximately 20% of the ocean floor using sonar and other remote sensing technologies, but actually seeing, visiting, and studying these places, that's happened for only a tiny fraction. More humans have walked on the moon than have descended to the deepest parts of the ocean. We have more detailed maps of Mars' surface than we do of our own ocean floor. The implications of this are staggering. We live on a planet where the vast majority of its surface and volume remains genuinely unknown to us. Think about what that means. When we talk about undiscovered species, we often imagine finding new insects in rainforests or small rodents in remote mountains. But the ocean likely contains hundreds of thousands of species we've never documented. Conservative estimates suggest that we've identified only about 10% of marine life. Some researchers think the true percentage might be closer to 1%. Every deep-sea expedition discovers new species, often multiple ones. In 2020, scientists surveyed a single seamount near Australia and found up to 30 potentially new species in just a few weeks of work. The Census of Marine Life, a decade-long international effort that concluded in 2010, added over 1,200 new species to scientific records, and estimated that perhaps 750,000 marine species remain undiscovered. This doesn't even include microorganisms, where the true diversity might be orders of magnitude greater. The ocean is essentially a biological dark continent, full of life we've never seen and ecosystems we don't understand. Consider that in just the past few decades, we've discovered entire ecosystems we didn't know existed. Hydrothermal vents weren't discovered until 1977, when scientists exploring the Galapagos Rift found volcanic fissures on the ocean floor surrounded by dense communities of strange organisms. These vents support life not through photosynthesis and sunlight, but through chemosynthesis. Bacteria converting chemicals from the vents into energy, forming the base of a food web that includes giant tube worms, white crabs, and species found nowhere else on Earth. We've since found hundreds of hydrothermal vent sites across the globe, and each one hosts unique species adapted to its specific chemistry and conditions. The discovery fundamentally changed our understanding of where and how life can exist. It demonstrated that sunlight isn't necessary for complex ecosystems, that life can derive energy from Earth's geological processes, and that biodiversity exists in places we thought were barren. What other types of ecosystems might exist in the unexplored ocean? Cold seeps represent another ecosystem type discovered relatively recently. These are areas where methane and other hydrocarbons seep from the ocean floor, supporting communities of bacteria, tube worms, mussels, and other organisms. Like hydrothermal vents, cold seeps host species found nowhere else, adapted to survive on chemical energy. We've found these ecosystems at various depths and in multiple ocean basins, but we certainly haven't found them all. How many cold seep communities exist in unexplored regions? The discovery of whale falls, dead whales that sink to the ocean floor, as specialized ecosystems came even more recently. When a whale dies and sinks, its massive body provides concentrated food for deep-sea communities that might not see such abundance for years otherwise. But whale falls don't just feed scavengers temporarily. They create succession ecosystems that can last for decades. First come the mobile scavengers like hagfish and sharks, stripping the soft tissue. Then come worms and crustaceans that consume the remaining flesh and bones. Finally, bacteria colonize the bones, metabolizing the lipids, and support communities of specialized organisms for years. Some species of worms and mussels are found only on whale falls, having evolved to exploit this specific ecological niche. They locate whale falls chemically, detecting the compounds released by decaying whale tissue from remarkable distances. The discovery of whale fall specialists raised fascinating questions about how these species persist. Individual whale falls are scattered across enormous ocean distances, yet these species manage to locate them and maintain breeding populations. How do they do it? We still don't fully understand the ecology and life cycles of whale fall specialists. Submarine canyons, deep crevasses carved into continental slopes, create unique habitats we're only beginning to study. These canyons can be thousands of feet deep and miles long, creating varied topography, unusual current patterns, and concentrated nutrients. They often host high biodiversity, but most have never been thoroughly explored. What lives in the thousands of submarine canyons around the world's continental margins? Seamounts, underwater mountains that don't reach the surface, number in the tens of thousands globally, but only a few hundred have been thoroughly surveyed. These underwater peaks create unique environments where deep currents are forced upward, bringing nutrients that support dense communities of corals, sponges, fish, and other life. Many seamounts host endemic species found nowhere else, having evolved in isolation on their particular mountain. When we explore a seamount, we often find species new to science. How many unique ecosystems exist on unexplored seamounts? The Hadal Zone, the deepest ocean trenches below 6,000 meters, remains largely unexplored despite being one of Earth's largest habitats. Only a handful of trenches have received significant scientific attention, and even those have been visited only a few times. The majority of the Hadal Zone has never been seen by human eyes or cameras. What creatures inhabit these deepest regions? Are there hadal ecosystems we haven't discovered? Recently, scientists found that the Hadal Zone hosts surprisingly high levels of biodiversity and unique species adapted to extreme pressure. Snailfish living at depths exceeding 8,000 meters represent some of the deepest living fish ever found. Strange amphipods, sea cucumbers, and other creatures thrive in conditions that would instantly kill most surface organisms. Each trench seems to host its own unique assemblage of species, suggesting that the trenches function as isolated islands of evolution. How many hadal species remain undiscovered? Even in relatively shallow coastal waters, new discoveries continue. In 2020, scientists discovered a massive coral reef off the coast of Tahiti at depths of 100 to 200 feet, depths that should have been well explored. This reef, stretching for nearly 2 miles, had somehow remained unknown despite being in relatively accessible waters. It consisted of giant rose-shaped corals in pristine condition, undamaged by the coral bleaching and degradation affecting many shallow reefs. The discovery suggested that there might be a twilight zone of deeper reef ecosystems we've largely overlooked. The ocean's interior, the vast volume of water between the surface and the bottom, remains particularly mysterious. We think of the ocean as having a surface layer where most life exists and a bottom layer with specialized deep-sea communities. But the middle layers, spanning thousands of vertical feet, contain their own ecosystems that we barely understand. The mesopelagic zone, from about 600 to 3,000 feet deep, hosts enormous numbers of fish and other organisms that migrate vertically each day, rising toward the surface at night to feed and descending during daylight to avoid predators. This vertical migration might represent the largest animal migration on Earth in terms of biomass. Yet we know relatively little about the species involved or how the ecosystem functions. Bioluminescence research continues to reveal complexity we didn't expect. Scientists keep discovering new forms of bioluminescence, new chemicals that produce light, new ways organisms use light to communicate, hunt, or hide. We're still cataloging which species produce light and how. The mesopelagic zone is essentially a realm of living light, where almost every interaction involves bioluminescent signals, yet we're just beginning to develop the tools to observe and understand this communication network. Large animal discoveries continue as well. The megamouth shark, a 18-foot-long filter-feeding species, wasn't discovered until 1976, when one became entangled in a Navy anchor off Hawaii. Since then, fewer than 100 specimens have been observed. A filter-feeding shark larger than a great white remained unknown to science until the late 20th century. What else might be out there? In 2003, scientists identified a new beaked whale species, Perrin's beaked whale, based on strandings and sightings. In 2016, another new beaked whale species was announced, Ramorie's beaked whale. Beaked whales are medium-sized whales that dive to extreme depths to hunt squid. And they're so elusive that several species are known from only a handful of sightings or from skeletal remains. How many large marine mammals remain unidentified? The discovery of new whale species reminds us that even charismatic megafauna, large, conspicuous animals that should be easy to notice, can evade scientific documentation for surprisingly long. If we're still discovering species of whales, what else lives in the ocean that we haven't found? The ocean is large enough, deep enough, and complex enough to hide even substantial animals in its vastness. The exploration gap isn't just about species. We don't fully understand ocean currents, particularly deep-water circulation. We're still mapping underwater topography and discovering seafloor features. We don't know the full extent of mineral deposits, volcanic activity, or geological processes. We understand that underwater landslides, methane eruptions, and other geological events occur, but we don't know their frequency, distribution, or full implications for ocean chemistry and life. Climate change is revealing how much we don't know about ocean processes. As waters warm, species are shifting ranges in ways we couldn't have predicted because we didn't fully understand their ecological requirements. Ocean chemistry is changing as waters absorb more carbon dioxide, but the full effects on marine organisms and ecosystems remain uncertain because we didn't establish comprehensive baselines for comparison. We're discovering that ocean systems are more complex and interconnected than we realized, with changes in one region affecting distant areas through mechanisms we're still working to understand. The ocean's interior contains massive structures we're only beginning to document. Oceanographers recently discovered that some ocean eddies, rotating masses of water that break off from major currents, can extend from surface to seafloor, creating moving cylinders of water hundreds or thousands of feet tall. These features transport heat, nutrients, and organisms across ocean basins in ways that affect climate and ecosystems. Yet we've only recently developed the ability to detect and track them. Underwater sound has revealed another layer of ocean mystery. Hydrophones, underwater microphones, pick up sounds we can't identify. The bloop was eventually explained, but other recorded sounds remain mysterious. Upsweep, a sound that has been detected regularly since the 1990s, appears to be seasonal and might be related to volcanic activity. But its exact source remains uncertain. The ocean is full of sounds whose origins we don't understand, creatures calling in frequencies we're just learning to detect, and acoustic environments we're only beginning to map. The exploration gap also extends to understanding how ocean ecosystems function at large scales. We know that phytoplankton in the surface ocean produce approximately half of Earth's oxygen through photosynthesis, but we're still learning about what controls phytoplankton populations, how climate change affects them, and what consequences shifts in phytoplankton communities might have for the entire planet. These microscopic organisms support the base of the oceanic food web, yet their ecology involves complexity we're only beginning to appreciate. Why haven't we explored more of the ocean? The challenges are significant. Ocean exploration is expensive, requiring specialized equipment and vessels. Pressure at depth makes reaching the deep ocean technically difficult. The ocean's vastness means that comprehensive exploration would require resources on a scale that humanity has not yet committed. Water blocks electromagnetic radiation, making remote sensing techniques that work for planetary exploration ineffective in the ocean. You can't take pictures of the ocean floor from satellites. You have to go there with vehicles, cameras, and sensors, which is slow, expensive, and limited in scope. But perhaps the main reason is simply that we've directed our exploration efforts elsewhere. Space exploration captures public imagination and government funding in ways that ocean exploration often doesn't. We've sent probes to the edge of the solar system and rovers to Mars, accomplishments that are genuinely remarkable, but we've barely scratched the surface of exploring our own ocean. This isn't necessarily wrong. Space exploration yields valuable scientific discoveries and technological innovations. But it does represent a choice about where we focus our curiosity and resources. The unexplored ocean represents opportunity. Every expedition discovers something new, whether it's a new species, a previously unknown ecosystem, or a geological feature that changes our understanding of ocean processes. As technology improves and becomes more affordable, exploration accelerates. Autonomous underwater vehicles can now map and survey areas without requiring expensive ships and crew. Sophisticated cameras and sensors can operate for months at depth, recording data continuously. Satellite technology, while unable to see through water, can track surface features and biological activity that provide clues about what's happening below. The unknown ocean should excite rather than frighten us. Yes, there might be more discoveries like the giant squid, real creatures that seem mythological in their scale and strangeness. There might be species that challenge our understanding of where life can exist and how it adapts. There might be ecosystems functioning in ways we haven't imagined. But these discoveries enrich our understanding of life, expand our appreciation for the planet we inhabit, and remind us that Earth still holds genuine mysteries. The ocean's unexplored vastness is humbling and inspiring in equal measure. Humbling because it reminds us how limited our knowledge remains, how much of our own planet we don't understand. Inspiring because it means there are still frontiers here at home, still places to explore, still discoveries waiting to be made. You don't need to travel to other planets to be an explorer. Earth's ocean provides more than enough mystery to last for generations of scientific investigation. Tonight, we've descended together into the ocean's depths, following sounds that echoed across thousands of miles, tracing legends from sailors' tales to scientific discovery, exploring trenches deeper than mountains are tall, and contemplating the vast mysteries that remain in the 95% of the ocean we haven't explored. The deep sea reminds us that Earth still has frontiers, that wonder doesn't require looking to distant stars when so much of our own planet remains unknown. And perhaps most importantly, we've learned that skepticism and wonder aren't opposites, that understanding the truth about the ocean makes it more fascinating, not less. Thank you for joining me on this journey through the deep sea's mysteries. If you're already drifting off, then our mission is complete. But if you're still awake, perhaps another deep dive through one of our previous episodes will carry you gently into slumber. Until we meet again in these quiet hours, may you find peace in knowing that Earth still holds secrets. May the unknown inspire curiosity rather than fear. And may you always remember that the most extraordinary discoveries often await in places we've overlooked.